We're running a couple of minutes behind.
Really nice for her to get
How are you
something.
feeling?
Good. It's much more relaxed this year.
Good, good. So having that experience last year really helped. Do you know what? You'll find that that happens every single week as you go along. You
Yeah.
just get more and more and more confident. I'm going to adjust your board slightly so that all of us can see the great things that you have on here. I'm gonna open it up a little bit more. Is it feeling like it's going to... There we go. So there's no possibility it will tip.
So,
We'll get to it.
Hannah, I know that we're a little late getting started, but I don't want you to feel rushed. We don't have a 10 o'clock, so don't feel like you have to rush to get through everything. Now,
Okay.
don't take, 45 minutes, but, don't feel rushed. Okay, so breathe deep, you're fine, all right? We're gonna sit, you're gonna talk to us, we're gonna listen to you, you're going to tell us everything you know, and what you learned, the incredible, wonderful, interesting things that you learned and that you did. After that, we'll have some question and answer time for you, okay? I'll ask some questions, Ms. Ryan will ask some questions. Once that's done, we're gonna have you come and sit right over here. And then we'll just give you some feedback. I'll give you a little bit of feedback on your presentation skills. Ms. Ryan will talk about the content of your presentation. And then you'll be set to go and ready for spring break. I'll be timing you.
Okay.
Got my stopwatch here. I'll hit this when you start talking, just like when you're doing a presentation in my class, okay? If you get to 4 minutes, I'll do this, okay? All that means is, I don't want you to freak out when I do that. All that means is you have 1 to 2 minutes to wrap your presentation up. Okay. If you get to 6 minutes, though, that's when I cut you off and we're all done, even if you're in mid-sentence. So keep that in mind when I tell you 4 minutes that you need to be working towards the end of your presentation. Okay?
Remember, when you're done speaking, you're going to stand there, right? So don't go sit down. Okay.
All right, so when you're ready, Hannah, you can begin.
Hello, my name is Hannah Bikini and I'm in 6th grade. I'm going to start off by defining density. Density is a measure of how much matter there is in a certain amount of space. It's measured by mass divided by volume. Relative density is a comparison of two or more different substances. Surface area is the covering area of a multidimensional body, and size is the relative extent of how big something is. And finally, my IV for this experiment was volume. Volume is the amount of space something takes up. It can be measured by centimeters squared if it's 2-dimensional, centimeters cubed if it's 3-dimensional, or displaced water. I used displaced water to measure my boats. It was a method invented by Archimedes in the story of the Golden Crown. I filled a 1,000 milliliter graduated cylinder to the 900 milliliter mark. I then placed one of my boats in the water. There was always an increase in the water level once the boat was added. I then took a eyedropper and sucked out the water to put it in a 10 milliliter graduated cylinder until the water level in the 1,000 milliliter graduated cylinder went back to the 900 milliliter mark. However much water was in the 10 milliliter graduated cylinder was the volume of my boat. My hypothesis was if the volume of the boat increases and the density of the boat at the time it sinks stays the same, then the amount of cargo it can carry before it sinks will also increase. As shown by my results, this hypothesis was supported. The 7.8 milliliter boat held the least amount of pennies at around 78 pennies. The 13.2 milliliter boat held neither the most nor the least amount of pennies at around 189 pennies. And the 23.7 milliliter boat held the most amount of pennies at around 162 pennies. Also shown by my graph, there's a positive correlation, meaning that the y and the x-axis both increase at a positive rate, showing that the results were conclusive. Some of the observations I took were that the pennies were added too quickly, which caused the water to shake from time to time. Also, some of the edges were folded lower or teared because I used the same boat for all 6 trials. And you might be wondering, for the 23.7 milliliter boat in this trial 6, why it's so low at 104 pennies instead of at the regular rate of 250 pennies to 280 pennies. That was because the pennies were thrown in rather than placed in gently. So there were even more sources of error in this trial besides the 23.7 milliliter boats. Some of them were that the pennies were added too quickly, and they were distributed unevenly. Because like some were on one side and the rest were on the other side. There's some changes I could make to this experiment too, based off of these results. I could change the materials of the boat from aluminum foil to maybe wood or a different kind of wood metal. Based off of these changes, I could also change the experiment entirely. The problem would be to determine the effect of the type of materials a boat is made out of on the amount of cargo it can carry before sinking. If this experiment had a positive result, it could be good for the whole world of water transportation. And we're always told we should relate our experiments or work to the real world, so this would be a great experiment to do that with. In all, I was very happy that my experiment my hypothesis was supported and my results were conclusive. And I couldn't have done it without the help from Google, long ago children's and stories. Wiki Answers, and Mrs. Gattell. Thank you for taking your time to watch my presentation.
Okay. Hannah, your hypothesis, what led you to your hypothesis?
Well, in the quarter 2 of science, he learned all about how to write our whole experiment and volume and I thought since the bigger something is it takes up more space, so it could hold more, and that's the only reason why I picked my hypothesis.
Okay, all right. What is the difference between volume, mass, and weight?
Well, volume is the amount of space something takes up. Mass is how much matter there is in a certain amount of space, and then weight is what keeps a mass down on the ground with gravity. So.
Okay, all right. Let's talk about your variables. Okay, how would you first off define independent and dependent variables?
Well, independent variable is the variable that can be independent on itself. It doesn't need anything else to help it. While dependent variable depends on the experimental controls, and it's the variable that can be changed. For mine, the amount of cargo it can carry. There was always a different amount of cargo capacity that it could hold.
So what variable changes, either the independent or the dependent variable?
The dependent.
The dependent variable changes. Okay. You said experimental controls. What is an experimental control?
It's what needs to be controlled in an experiment so your results aren't altered by something funky.
Okay.
One of my experimental controls was the temperature of the water, and I always kept it at room temperature because one of the other experiments was temperature of the water, so I knew I had to keep it at the same temperature. So if it was colder, it wouldn't sink faster or float longer.
Okay. And what if you didn't control that? What is the potential?
You could get weird results.
Okay.
For trial 6 of the 23.7 milliliter boat, it had 204 pennies. And that was because I throwed it in, and one of my experimental controls was keeping it at a positive rate, so evenly distributing the pennies.
Okay, yeah, I was curious about that, and maybe I just am not understanding what you're saying. In that one particular instance, why did you throw them in as opposed in the other experiments? Did you just set them in there?
Yeah.
Okay. Why did you throw them in there?
I didn't mean to throw it in there, but I was starting to get better at putting them in, so I had them in stacks of 10, and then I just dropped them in instead of placing them in nicely.
Okay. All right. Interesting.
Which one? I'm sorry. Which one was that for?
Trial 6 of the 23.7 milliliter boat.
Oh, okay. No, it's fine. I just wanted to know which one we're talking about.
Is there any other related experiments that you might have done in class that was related to yours?
Not that I can think of off the top of my head.
Okay, all right. What was your source of error?
Some of the pennies were distributed unevenly, so some stacks of 10 were put on like the right side of the boat, while all the rest were put on the left side of the boat.
Okay, and did you do anything to fix those sources of error?
Well, as soon as I noticed it, I put it down in my observations when I was doing the experiment, so that I knew who I needed to not do that. And sometimes it took longer than others to get it, so they were completely even, because it can't all be even.
Okay. You have an inference on your board there, Hannah. What is the point of that? Why do we have an inference in an experiment?
To show your sources of error, her changes you would make to your experiment, and a new experiment based off of your results.
Okay. If you would do anything differently in this experiment that you did, what would that be? Or if there were multiple things, what would you do differently?
I would change the type of cargo used from pennies to marbles.
Okay. Why is that?
Because I think marbles are more consistent, where pennies, there's different years, so they might have different weights depending on the year.
Okay.
And they might be made of different, there might be the slightest bit of different metal in each of them.
Okay. All right.
I'm just going to go off of what you're saying right now. You did a really great job. Why would different weights of pennies have an impact on your experiment?
Because if there were different weights, I'd be putting, instead of putting the same pennies in, I would be putting different weights, which also could have altered my results.
Okay, so what causes the different weight in the pennies?
Well, I'm not sure exactly. I just assume that depending on the year, here they change the kind of pennies, and maybe their metals. Some of them could be really big, and some of them could be really small.
Are pennies different sizes?
No, they are not.
They're not different sizes, so what's changing about them if the size isn't changing?
Maybe the metals they're using.
And that changes the
weight, because some metals are heavier
well,
than
let's
others.
relate it back to your experiment. Right? So what's different about the pennies? If they weigh more, that means something is different about them.
The mass is different.
The mass is different. The mass is different. And if the mass has a greater mass in the same amount of space, right, then what else is different?
The density.
Yes, the density is different. Okay, that's excellent. So now, I was just so curious. I saw that if you had the volume of the boat increasing, but the density of boat stays the same. How did you change the volume without changing the density of the boat?
Well, the density is the matter, and I use the same boats for each of them, so I'd have a consistent volume, so I wouldn't have to do displaced water over and over again, because even if I made the same size of the boat, it could have a different volume.
I'm backing up even a little bit further than that. So before you've done your experiment, you're making your boats, right? So how do you create boats that have different volumes but the same density?
Well, I use the same I used heavy-duty aluminum foil, and I used the same layers of it, and I only folded it. Some of them were bigger than others, but it all takes up the same. It all has the same matter.
So how do you know it has the same matter? What did you do? How did you control that?
Well, the type of aluminum foil, or
So describe how you made your smallest boat to me.
well, I just cut a pieces of aluminum foil, so it was like a perfect square, and then I folded it the way Mrs. Gattell showed us to fold our boats.
How big was the square? Do you remember?
The square was, I think it was 12 by 12.
Okay. So now go to the medium-sized boat. How did you make that one?
I did the same thing, except I made the square bigger.
So if the square is bigger, then you have more aluminum foil.
Yeah.
If you have more aluminum foil, wouldn't that make a greater mass?
Yeah, I guess so.
So looking back in retrospect on this, do your boats all have the exact same mass?
No.
That is interesting. That is really interesting. Okay, so when you were doing the displacement, when you were measuring your boats, is this a picture of you doing the displacement right here?
Yeah,
when you
that's
put
the
them in?
boat in the water.
Did the boats crinkle up
Well, we had to fold them in, but it would still have the same volume because it would take up the same amount of space, sort of.
What would take up the same amount of space?
The boat would, because even if you folded it, it still takes up, it still has the same mass, as in it takes up the same amount of space still.
Okay. All right, so now we're kind of looking at it and you realize that the masses of the boats weren't exactly the same, which is totally fine.
Yeah.
Totally fine. But now how does that change your experiment at this point?
Well, it could have also altered my results because I didn't have it as one of my experimental controls, but that should have been one of them because if they had the same amount of mass, it would just be the volume of the boat, not the volume and the mass of the boat.
Very good. That's all the questions I have.
Okay.
Have a seat.
Come on, have a seat.